us going. All right. Stick roll, Veronica. Daniela, not here. William is here. Jack is not here. Gracie. Jacqueline. Melanie is not here. Christopher. And Emmanuel's not here. All right. to do that? It's weird. Give me a second. One of the elements for my stream is broken. Okay, it's working now. Okay, so last time we were talking about standard deviation. And standard deviation allows us to start parsing out how our data is distanced in relation to other data points. So one way that we saw was helpful with standard deviation is we can find where most of our data lies. It should lie within one standard deviation of the mean. Okay? Now, there are other ways to measure how data is distanced from all the other data points, and that is through percentiles. Standard deviations are still kind of percentiles, but we can calculate a bit more finely using some other methods. So let me give you an example. So I've got a rather large data set here. 6, 13, 3, 22, 5, 17, 18, 21, 22, no, 2, 1, 4, 15, 2, 16, 14. Like I said, very large set of data for our purposes. All right. So again, what we can do is we can start calculating percentiles a different way. Well, one way that we could break this up is in quarters. Okay. Now, if we're going to be breaking up our data or really processing it in any way, it's always a good idea to put in order first. So let's rank our data. We've got 1, 2, 2, 3, 4, 5, 6, 13, 14, 15, 16, 17, 18, 21, and 22. So like I was saying, what we can do is we can break this up into quarters, and then we would know, well, there's 25%, 50%, 75% of our data. We know what quarters look like, you know. Okay, so that's actually pretty easy to do, and we've done a few of the steps already before. The first step is to find the median. So we're going to find the middle of our data here, and that will give us 2 halves. So we'll split our data into halves. So let's see, where's our median here? So we count in from each side. And we get 13. 13 is directly in the center of our data. Again, this is our median. But this also represents the 50% mark of our data. So by the time we get to our median, we have seen 50% of our data. Does that make sense? Okay. Now, if we want to break this up into more percents, we can do basically the same thing we just did. just instead of looking at the whole data, we will look at just this side of the data and find the median there. So what's the median of this side? 3. Same thing on the other side. What's the median of this side? 17, yeah. Good. So this one represents the first quartile, which we can note by saying Q1, and it is 25%. So again, what I mean by that is by the time we get to this number here, we've seen 25% of our data. This right here is our third quartile, and it represents 75% of our data. So again, once we get to this point, we've seen 75% of our data. Okay, well, Mr. Hardison, you skipped over the second quartile. Actually, median is the second quartile. Okay, so again, we get to here, we've seen 25%. We get to here, we've seen 50. We get to here, we've seen 75. These are our quartiles. Again, what we've done here is we've broken this up into quarters. Now, when we do this, it's also useful to know our smallest number and our largest number. So our minimum and maximum values. Okay? Any questions? None? All right. What we've just done here is something called a 5-number summary. So 5 number, 1, 2, 3, 4, 5 numbers. And the summary, what it basically does is it says, okay, here's a basic glance at how this data is distributed. Now, a better way of representing your 5-number summary is with a graph. In particular, a box and whisker plot. So let me make a graph for us real quick here. That's not going to be big enough. Make this a bigger one. So we'll say this is 0 and this is 30. Means this middle one is 15. Okay. So now what we'll do is we will take each of these 5 numbers and plot them on here. Okay. So let's see, this one right here is about 7.5. So 1, it's about right there, 3, 13 is going to be over here. 17 is going to be somewhere out here. And then 22 is going to be over here. Approximate distances. And the way we set up our graph for this is that our quartiles are in a box. put that one in a box. Ignore that line. But our quartiles are in a box. And we can see that even though they should be evenly distanced from each other, you know, this is 25, this is 50, this is 75, the range from our 25% mark and our 50% mark is very different from our 50% mark and our 75% mark. And then we have our minimum and maximum. So this is called a box and whisker plot. So box and then the whiskers on the outside. And again, what this shows us is the relative distance between our percentiles. So how is this thing actually spaced? Well, you can imagine that if we had all the numbers between 1 and 22, but we had no repeating numbers and we had every number represented between 1 and 22, all of these distances would be exactly the same. They'd be perfectly even. But that's not what we have going on in our data. Some of our numbers repeat. We're missing numbers in between some of these. So like from 6 to 13, we're missing a bunch of numbers there. So this affects the distances that our percentiles actually cover. So again, from our 25 to 50%, there's a lot of distance there. And then from our 50% to our 75%, there's not really a whole lot of numbers covered there. So this gives us an idea of how our data is distributed. You know, is it distributed really evenly? Is it distributed lopsidedly? What have you? Any questions? None? Okay, let's try another one of these, get some more practice. Yeah, this looks like a good data set. Let's try 8, 7, 12, 12, 7, 13, 6, 5. So again, the first thing we want to do is find the median here, so we need to put this in order from least to greatest, or rank our data. So go ahead and help me do that. What's going to be our first number? 5. Keep going for me. 6, 7 and 7, good. 8, 12 and 12, and then what? 13. Excellent. So we've got our data arranged here from least to greatest. Now we want to find that median. So where's our median here? Not quite. 7.5, yeah. The problem here is that if we count in from each side and try to find our middle number, we actually have two numbers in the middle. So we've got to find the number between them, which is 7.5. Good. So our median occurs at 7.5. Okay. Now again, we want to do the same thing with each side of our data. So just looking at this side, what's going to be our median here? 6.5, yeah, right there. So there's our first quartile. Okay, looking at this side of our data, what's our median? $12, yeah. So both things on the each side of the median are 12. So yeah, if you were to do 12 plus 12 divided by 2, you'd get 12 again. So our median actually is 12. So Q3 is 12. Okay. And what other two numbers do we really like to have when we're doing these 5-number summaries? Minimum and what? Maximum. So our minimum number and our maximum number. Very good. All right. So let's go ahead and plot these down. Now let's see. I'm going to need something that at least covers from 5 to 13. I think I'll go from 0 to 15. So let's see. One, four, all right. So again, we got 0 to 15 here. So just plot all the numbers down. Let's see. So first number is 5. 1, 2, 3, 4, 5 is right there. Next we have 6.5. So 6.5 is right here. Then 7.5 is right there, right next to it. Next one is 12. Is right here. And then 13 is right next to that. Okay. So draw my whiskers in and then draw my box around that. And there we go. There's our box and whisker plot. So again, we can see here, we've got basically the opposite way. From 25 to 50%, there's almost nothing covered. And then it takes a long distance for us to get to the 75% mark. So again, this allows us to see how even or lopsided our data is. And it uses percentiles. So just to cover that one more time, this is like 0%, this is 25%, this is 50%, this is 75%, and this would be 100%. Any questions? None. All right. Making sense though? Good. Okay. So again, this is another way that we can break up our data, is breaking it up by quarters, finding those quartile ranges. Okay, so again, we have the first quartile, second quartile, and third quartile. Now, that's fine to be able to find those really specific percentiles. But what if we want to find our own percents? What if we don't want to follow quarters? What if we want to follow whatever percent we want to use? So be able to find, well, maybe like the 61st percent position. Okay? Well, we can absolutely do that. Let me just get some data here. Actually, why don't we use the same data? That'd be interesting. So, we use the same data from the previous one. I'll keep the ordered version. Okay. It's the same data, but instead of trying to find 25, 50, or 75%, let's try to find 30%. So at what point have we seen 30% of our data? That's the question we're asking here. Okay, it's actually very, very simple to do. Here's the formula for it. K times N equals our index. The index is just how many numbers you have to count before you get to your 30%. So like, if our index came out to be something like 4, we'd count 1, 2, 3, 4, and there'd be our percent mark. Okay, so what is K? K is whatever percent we have as a decimal. And n, what is n? We actually already know this. Is what? I can't quite hear you. It's the amount of numbers we have. So how many data points we have. But yeah, you're on the right track there. So n would be just how many data points we have in this set, which for this one is 1, 2, 3, 4, 5, 6, 7, 8 numbers. So we do our k times n to get our index. So k, what is 30% as a decimal? Well, do what? 0.3. The way you find what it is you divide by 100. Okay, so k is 0.3 in this case. N, again, what did we say our n is here? 8. So we do k times n, or 0.3 times 8. So let's see what that comes out to be. 0.3 times 8 is 2.4. Okay. Now at this point we need a whole number. We don't want to take partial steps. We want a whole number. So 2.4, if we round that to a whole number, is what? 2. Yeah. So our index is 2, again because we rounded it. So what this says is we need to take 2 steps before we get to the 30% mark. So 1, 2, that'd be 6. Okay, any questions? Let's try to find something like the 80% mark. So 80% as a decimal is what? 0.8. So that's our k. What's our n? 8. So k times n, 0.8 times 8 is going to give us 6.4. So what's our index? 6. So 1, 2, 3, 4, 5, 6. There's our 80% mark. It's just that easy. Any questions? No? Okay. So maybe back in high school you remember getting like a grade towards the end of your semester, senior year, and it ranked you to the rest of your class, right? So maybe you were in like the upper 20%. Okay? Upper 20% means that you're above 80% of the rest of the class, right? So if this is 80%, you're in this part. You're in the upper 20. If you're in the one of my poor friends in high school was in the bottom 5% of our class. So if you're in the bottom 5%, you're all the way back here. Okay, so these percents that they calculate for that sort of thing, this is how they're doing it. They're taking all the data points, so everybody's grade, or really GPA in this case, it would be, and then they're finding percents. So where is our 5% mark? Where's our 10% mark? Where's whatever marks they want to do? And then once they have those, they can categorize your particular grade into whatever percent class they want. Okay? And so that's how you get that grade. Any questions? All right, let's try this one more time. New set of data. Looking for a good set. That one's okay. Okay, so we've got 49, 59, 60, 67, 69, 72, 75, 81, 86, 88, and 93. Okay. So luckily this is already in order for us. We don't have to order it ourselves. And let's find a percent. Doesn't matter to me. Somebody yell out a percent to me. 53. Is that what I heard?
Yeah.
All right. So 53%. So what is our K? 0.53. What is our N? 11? Okay, so then we need to do K times N. So 0.53 times 11 gives us 5.83. Yeah, I entered it wrong the first time. Okay, so if it's going to give us 5.83, what is our index? 6. So we count 1, 2, 3, 4, 5, 6, and this is where 53% has been reached. Okay. Now, something I want to point out here. Not exact. Okay? If you wanted to be exact, if you put these on a number line like we did for these, these points, K times N, would be these decimal things, and they would be somewhere in here. Now we want whole numbers because we want to be able to find where we have reached 53%. This is not exactly 53% of our data. This is where we have reached it. So somewhere in here is actually between 69 and 72 is actually where we have gotten to 53%. But so that we know where in our data that actually occurs, not just some number between our data points, but actually a data point, we use a whole number to figure out where that goes. Okay? Any questions? All right. One more thing I want to say before we go. I forgot to mention this last time when we were talking about standard deviation. So let's think about our standard deviation formula. And I'll use population, but this is true for both population and sample. So standard deviation is the square root of the sum of x minus mu squared all over n. Okay? So here's a question for us. When we do our standard deviation calculation with this formula, will we ever get a negative number? Okay. How do you know? Exactly, good. So that's an important thing to remember when we're dealing with standard deviations. Standard deviations can never be negative. And it's because, again, they are distances. Just like we were just working with these percents are distances. They're distances in our data. These percents, distances in our data. Standard deviations are the same. They are distances. And it comes from that square. So when we do x minus mu, yeah, we can get negative numbers from x minus mu. If it's below, if our x is below the mean, then that x minus mu is going to come out to be negative. If it's above the mean, then it'll be positive. But if we get a negative number from our x minus mu, when we square it, it becomes positive. Because if we have something like 2, or negative 2 times negative 2, or negative 2 squared, a negative times a negative is a positive. And so no matter what we have in here, once we square it, it will always be positive. And then summing is not going to change that. It'll still be positive numbers. Dividing will not change that. It'll still be positive numbers. And taking a root will also still not make it negative. It'll still be positive numbers. So remember, standard deviation, just like these percents, standard deviation is a distance. It's a measure of distance. And distances cannot be negative. I can't say that this room is, negative 10 feet wide. No, it doesn't make any sense. It's 10 feet. Okay? Any questions? All right, well, in that case, go a little early today. And I will see y'all later. Oh, remember, quiz on Friday. Same stuff as last quiz, but it'll add in standard deviation and box and whisker plots.